Assalamu alaikum and welcome back to Chemistry World. I'm your instructor Wahaj. Today's the topic of our lecture is intrinsic angular momentum and origin of magnetism. So first we have to discuss intrinsic angular momentum. Intrinsic angular momentum is a term used in reference to angular momentum quantum particles have. So we have observed and predict with theory that particles have quantized angular momentum from Bohr's atomic model. So however, it is important to recognize that the classic formulas of angular momentum like L bar is equals to R bar multiplied by P bar, so L is equals to R XP don't apply because nothing is actually spinning. So an electron is a point particle, so it cannot spin around an axis like a baseball. So we therefore call this quantity intrinsic angular momentum. Because it behaves like angular momentum in every possible way, so it is in fact angular momentum but nothing is spin, so that's why we called it as intrinsic angular momentum. Now, origin of magnetism. One of the fundamental properties of an electron, besides that it carries charge, so is that it has a magnetic dipole moment. So it behaves like a tiny magnet producing a magnetic field. So this dipole moment comes from the more fundamental property of the electron, that it has a quantum mechanics spin. So due to quantum nature, the spin of electron can be in one or only two states, with the magnetic field either pointing up or down from any choice up and down. So the spin of electrons is in atom is the main source of ferromagnetism. So we can say that the ferromagnetism is due to the spin of electrons, although there is also a contribution from orbital angular momentum of an electron about the nucleus. So when these magnetic dipoles in a piece of matter are aligned point in the direction their individually tiny magnetic fields add together to create much larger macroscopic field. However, the materials made from atoms with filled electron shells have a total dipole moment of zero, because the electrons are all exist in pairs with opposite spin. So every electron magnetic moment is cancelled by the opposite magnetic moment of the second electron in the pair. So only atoms with partially filled shells, unpaired spins can have a net magnetic moment. So ferromagnetic only occurs in the materials with partially filled shells. Because of the Hund rule, the first few electrons in a shell tend to have the same spin, thereby increasing the total dipole moment. So these unpaired dipoles, often called simply spins, even though they also generally include orbital angular momentum, tend to align in parallel to an external magnetic field, an effect called the paramagnetism. As we discussed in our earlier lecture. So ferromagnetism involves an additional phenomena. However, in a few substances, the dipole tend to align simultaneously, spontaneously, giving rise to spontaneous magnetism even when there is no magnetic field. But when it placed in a magnetic field, it is strongly aligned in the magnetic field, and it contains the magnetic field even after the removal of external magnetic field. So this is our today's lecture. If you like that video, please share, subscribe, and don't forget to press the bell icon. Thanks.